Morning students, my name is Joseph Okoth, a teacher of physics. In our last lesson we looked at the properties of the X-rays. Today we want to start by looking at the types of the X-rays, and there are majorly two. We have the soft X-rays and also the hard X-rays. We are going to start with the soft X-rays. Why do we call them soft X-rays? They are soft because they are produced by electrons moving at a lower velocity as compared to those ones of hard X-rays. This low velocity is achieved by varying the current in the production tube. The X-rays are used to show malignant growth in tissues because they only penetrate the soft tissues. The quality and type of X-rays produced is determined by the accelerating potential. Remember, we can vary the current, we can raise it or we can lower it. So when we raise it, we produce more X-rays, and when it is lowered, less X-rays are produced. Intensity of the X-rays. This is controlled by the amount of heating current. The larger the amount of heating current, the higher the intensity of the rays produced. And the lower the current, the lower the intensity. The greater the heating current, the greater the number of electrons produced, hence more X-rays. And to give more intense beam of X-rays, the cathode is made hotter to give more electrons, leading to more X-rays. We have the applications of the X-rays. One in medicine, which is also referred to as radiography and radiotherapy. This is based on the penetrability of these rays. X-rays penetrate soft tissues and it's being blocked by hard tissues. In the hospital, this is used to determine the fractured bones or dislocations within the joints. The X-ray produces this in the process known as the radiography. Foreign objects which can be swallowed by by a child or human beings, and this could include coins or some small pieces of metals. They can easily be located by the use of the X-rays. Now, hard X-rays are used to treat cancer or tumors and even some of the skin diseases, since they destroy these infected cells and in the process prevents further multiplication of the cell or the disease-causing cells. In science, X-rays are used in the study of crystal structure, which explains the arrangement of atoms in different materials. In this case, there are fractures. There are fractures in the structure. Sorry, in case there are fractures in the structure of the material, they can easily be revealed by the X-rays. Then we have the application in industry. In industry, they can be used to inspect or detect flaws in the metal casting. They can also be used in sterilization of the surgical equipment before use. They are also applied in security, e.g. in the airports, to inspect the luggage of any weapon hidden in them. And all manner of luggage can be inspected by use of these rays. Dangers of the X-rays. As we stated before, these rays can ionize air, or it can ionize, they have ionizing property. This is very dangerous because it can cause damage to the body cells. Excess exposure to the tissues can also cause some damage, and therefore we should be able to avoid the exposure as much as we can. The penetrating property can also cause genetic mutation or changes, and therefore this explains how dangerous these X-rays are. We should avoid them as much as we can. Next, let's look at some of the precautions that we are supposed to take. X-ray machines are supposed to be blocked or shielded by lead material. Lead is very thick and therefore can stop the penetration of these rays, and with that we will be able to control it such that it does not affect the users or anybody who is exposed to them. Another precaution is that the rooms where these rays are being produced must be constructed using brick walls and even the lead materials. Again, this stops any astray rays from entering or getting in contact with the environment. Finally, we have to reduce the exposure time. Even to the sequence, when somebody is being taken to the X-rays, the exposure time is being reduced totally, because overexposure can bring other problems. Next, we have the energy of the X-rays. As you can see, the energy is given by E is equal to hc over lambda. H is the Planck's constant and c is the speed of light, and lambda there is the wavelength. Energy can also be given as E is equal to EV. EV here is the electron volt. Once we have the electron and the voltage, we are able to calculate the energy that is being produced by that given X-ray, which is also summarized as EV is equal to hc over lambda. The energy of the electron is maximum when the wavelength is shortest. It is also minimum when the wavelength is longest, and vice versa. Finally, we have some of the problems involving the X-rays, as you can see. Question 1. Calculate the wavelength of X-rays whose frequency is given by that. Now, in this case, we have the frequency. We know the speed of X-rays. Given that it's an electromagnetic wave, the speed is the same as that of light, and therefore we can now get the wavelength by simply substituting in the equation. C is equal to lambda f. Same applies to question 2, question 3, like that, and question 4 and 5. I want you to go through these questions from question 1 up to question 5 and practice solving these problems involving X-rays. Up to that point, we have come to the end of the lesson. Remember the equations involved in the X-ray production, that is C is equal to lambda f. We also have the equation involving the energy. E is equal to h, f, and all that. Make use of those equations to solve the problems given on the board. Up to that point, we have come to the end of this lesson. Let's meet next time.